Why is math so important to science? In the previous video, we went over the steps of the scientific method, and the fifth step was to analyze the results. But analyzing results in an objective way is very hard to do without a consistent system. After all, stating that the rainfall tomorrow will be heavy is not that useful, but saying the amount of rain tomorrow will be at least 5 units is much more helpful. And whatever your unit is, others can independently test your hypothesis. We have used math to help measure things for tens of thousands of years. Evidence of basic arithmetic dates back at least 40,000 years, and carved tally marks in bones. We do not know what these ancient humans were counting, but it is not hard to imagine wanting to count a variety of things. Other than basic arithmetic, humans have been using other kinds of math for a long time, especially in the construction of buildings, because having a knowledge of geometry and trigonometry is very helpful. Almost any high school geometry student could recite the Pythagorean Theorem in her sleep. A squared plus b squared equals c squared. Knowing how the length of triangles interact with each other is very helpful when building just about anything, but when the theorem was first conceived, it was not in the form we see today. In fact, algebra had not yet been invented. In its original form, it was written, "The square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides." The application of mathematics in science is not limited to just measurements, though. In fact, having a greater understanding of math can result in better observations and better measurements. Take Isaac Newton's work in optics. In the late 1600s, the behavior of light and the concept of light itself was not well understood. Newton was interested in studying light, especially in the way light refracted through a prism. After several well-thought-out and careful experiments, Newton created equations to describe the way light behaved. Newton used this knowledge to build the world's first reflecting telescope, which resulted in better measurements of objects in space and is still the primary design for telescopes we use today, including the Hubble Space Telescope. Newton's understanding of mathematics led him to discover calculus, which continues to be the foundation of much scientific thought over 300 years later. Okay, so math is useful in observations and analyzing results, but does it have any other uses in the scientific method? To answer this question, let's turn to a scientific paper that completely changed the way we view the universe. Written by Albert Einstein, the general theory of relativity is a theory of gravity, a subject that hadn't been advanced since Newton published Principia in 1687. In the paper, Einstein described a universe in which space and time were the same thing, space-time, and space-time could be warped by mass and even change the flow of time. These equations were then used to predict the existence of black holes a year later, a concept that Einstein did not believe, and even 20 years after the prediction of black holes, he did not find the idea convincing, and wrote that black holes do not exist in the real world. We now know Einstein was wrong, and in 2017, astronomers were able to take a picture of a black hole for the first time. Black holes are such a great example of why math is the language of science, because Einstein's mathematical reasoning was so powerful, it was used to predict a phenomenon that he did not believe existed. As you can see, nature can be illustrated through the language of math.